Okay, so this is a supplemental video, an additional video to the converse of the Pythagorean theorem. In the first video, we learned what that meant, that if the three values you have work in the Pythagorean theorem, then they form the sides of a right triangle, and we talked about what it meant to be a Pythagorean triple, that if they work in the Pythagorean theorem and their whole numbers, then they're a Pythagorean triple. This one is taking it one step farther. Not any different, we're still going to use the same math, but we're going to look at triangles that are on a coordinate plane, and we're going to decide if they work in the Pythagorean theorem or not, if they're a right triangle. So some stuff for you to recall here. I said this on the first slide, but what we're doing is we're checking to see if the sides of a triangle work in the Pythagorean theorem. If they do, then they form a right triangle. Now, if they work in the Pythagorean theorem and they also happen to be whole numbers, then they're called a Pythagorean triple. Okay? Now, these particular questions aren't going to ask you if they're a Pythagorean triple, but I'm going to use them to review what that idea means. Okay? So, first example here, is this a right triangle? Is that what they form? Now, you have two options, really. Okay, you can just jump right in and start doing work, which is what I'm going to do, or you can graph it first, and the advantage to graphing it first is that it gives you a visual. Now, you can't just base everything off of that visual. You do have to do the math to verify it. That's why I'm just jumping in to do the math, because that's the part I'm concerned with. That's the part that's going to tell you if it's right or not. The visual can confuse some people. So, like I said, we're just going to jump right in and we're going to do the math. And what we want to find here, we need the three values for the sides. Well, this triangle is going to have side AB, side BC, and side AC. We're going to use the distance formula, which we have used before, in order to figure out what the distance between these points are. If you've forgotten what the distance formula is, it is x1 minus x2 squared plus y1 minus y2 squared, and it's all underneath the square root sign. We're going to start with segment AB. I'm going to plug that into the distance formula. So 0 minus 0, x1, x2 squared, plus 2 minus a negative 1 squared. 0 minus 0 squared is 0. Okay, and then 2 minus a negative 1, that's really 3, because we add those together. And we're going to square that. 0 squared is 0. 3 squared is 9. So really this is the square root of 9. Now I'm going to take that one step farther here, because I know the square root of 9 is 3. Alright. Next thing I'm going to do, same thing on BC here. Square root of 0 minus 4 squared plus negative 1 minus 2 squared. Well, 0 minus 4 squared is negative 4 squared plus negative 1 minus 2 is negative 3 squared. That's really 16 plus 9, and 16 plus 9 is 25. So this is the square root of 25, which is 5. Okay. AC, last one. 0 minus 4, forgot my square root sign, squared, plus 2 minus 2 squared. 0 minus 4 is negative 4 squared. 2 minus 2 is 0. So that's really 16 plus 0, square root of 16. That is 4. Okay, so our three sides are 3, 5, and 4. Alright? What we want to do now is check and see if they work in the Pythagorean theorem. Something to remember is the biggest side, the hypotenuse, has to be the biggest value. Okay, so this is my C. We're going to check and see if a squared plus b squared does in fact equal c squared. Well, a squared, I can use either the 3 or the 4. I'm going to go with the smaller one. 3 squared plus 4 squared. I want to see if that equals 5 squared. Well, it's 9 plus 16. That is 25. 5 squared is 25. So yes, they are equal, and yes, this is a right triangle. We know that because the three values we found for our sides work in the Pythagorean theorem. Now, This one is also, these values also are a Pythagorean triple, and we know that because they are all whole numbers, 3, 4, and 5, and they work in the Pythagorean theorem. Okay, we'll do one more example. Same idea here. Is a right triangle formed? So you can graph it if you want, that'll help you give the visual, but we're going to jump in and start doing our work. We have our three sides, xy, yz, and xz. Square root of -2 minus -3 squared plus 2 minus -1 squared. Okay, 2 really plus 3, that's 1. And 2 plus 1, that's 3. It's going to be 1 plus 9, so this side is the square root of 10. Now looking at that, I know it's not going to break down. I know that that's not a perfect square. It's not going to become a whole number, so this is not going to be a Pythagorean triple. I can already tell that right off the bat. A shortcut, I am not even going to try to break down that 10, okay, and I'll show you why here in a second. But leave them on these particular problems as unsimplified radicals. So let's do yz next. Square root of -3 minus 2 squared plus -1 minus 0 squared. This is really -5 squared plus -1 squared, and that's 25 plus 1, so the square root of 26. Again, not a perfect square. Okay, I know this isn't going to make a Pythagorean triple right off the bat, and I'm going to leave that unsimplified. Last one here, xz, -2 minus 2 squared plus 2 minus 0 squared. That is really -4 squared plus 2 squared. Well, -4 squared is 16, plus 2 squared is 4. That is 20. Okay? Good. Like I said before, I've said this on each one of these, this is not going to be a Pythagorean triple. Those are not perfect squares. They're not whole numbers. We're still going to see if they make a right triangle, so we're going to plug them into the Pythagorean theorem and see if they equal each other. Remember, the hypotenuse has to be the biggest side. That would be my biggest radical here. That's one of the reasons I left them unsimplified, because my biggest radicand will produce the biggest decimal. Okay, we talked about that with our estimating the other day. So square root 26 is going to be the biggest, and I'm going to plug that in here for C. A can be either one. I'm going to use the smaller one. B is going to be the other one. Okay, now I said to leave these as unsimplified for this reason. When I'm squaring a square root and there's no coefficient out in front, what happens is those cancel each other out. So this becomes just 10. This becomes 20. So this side is 30. Now over here, I end up getting 26, and these are not equal, so they did not work in the Pythagorean theorem. That means this is not a right triangle. Okay, those are your two examples for this. Like I said, it's an extension of what we did on the last one. You're still plugging values into the Pythagorean theorem. You can still check and see if they're Pythagorean triples, but we're doing it on a coordinate plane, so we're adding that extra element of the distance formula in there. Be sure to ask me any questions if you have questions. Good luck on your Schoology assignment.